Hi, I'm Dr. De Bruin, and this is another A-level Chemistry exam question walkthrough from the transition metals topic. In the next video in this series, we're going to look at some of the maths and the calculations that are associated with the redox titrations. But in this video, we're just going to concentrate on a few of the fundamentals first. So firstly, when you do a redox titration and you use potassium permanganate, why is it so important that it's acidified? Well, this is because we want all of the manganate ions in that potassium permanganate to fully react to form Mn2+ ions. And the reason that that's so important is that as the manganese undergoes that shift, it changes oxidation state, and so therefore it changes colour, and therefore we can actually see where the endpoint is happening. Sulfuric acid is a good choice of acid for this because it's a strong acid. We wouldn't want to be using a weak acid like ethanoic acid. We don't need a pH indicator in this titration because it's a redox titration, so therefore it's self-indicating. So we see that colour change as the manganate ion changes to a manganese ion. Our overall ionic equation is going to have our 5 Fe2+ ions changing to be 5 Fe3+ ions, and that's going to happen because of this single manganate ion changing to make a single manganese 2+ ion. You can see that in the manganate ion we have 4 oxygens, so that's going to need to be balanced by 4 water molecules, and therefore on the left hand side we're going to need 8 hydrogen ions. So that's where our acid comes into play. Now with the colour change at the end of the titration, people often get a little bit confused here. So the change that you're going to see is that the solution will go from being colourless or potentially very pale green because of the ion 2+, to being pale pink. Now that often confuses people because if they look back at our ionic equation, you can see that the pale pink manganate ion is on the left hand side. But what you have to remember is that prior to the end point, there is still some ion 2+ left over. So every manganate ion that comes out of your burette and goes into that conical flask is immediately reacting with some ion 2+ and being changed into manganese, so it's disappearing. After the end point, there's no more ion 2+ left, so there's an excess of manganate ions, and that's when we start to see the colour change. So even though the manganate is a reactant on the left-hand side of the ionic equation, what we're interested in, the end point, is after this equation has run its course. It's also really important that you're talking about it becoming pale pink or maybe very pale purple, but you don't want to say the whole solution is going to go purple because it isn't. At the point of the end point, we've got a single drop of purple, and so it's just going to lend us this very, very pale colour. Thank you very much for watching, and I hope that you're finding these walkthroughs of A-level chemistry exam questions useful as part of your revision. If you are, then don't forget to like and subscribe, and also let me know in the comments which topics you'd like me to cover next.